Hello, everybody. I'm Dr. Bob Morris, professor of biology at Wheaton College in Massachusetts. Welcome to another episode of Science with Dr. Bob. Well, here we have another episode about one of the greatest threats to our planet right now, climate change. Massive amounts of evidence show that humans are driving the current sudden change in climate by a sudden addition of carbon dioxide to our atmosphere by the burning of fossil fuels. We're adding that carbon dioxide faster than the planet can handle it, faster than it can store it into rock or into plants or into forms that it will not change the climate very quickly. So consequently, our climate is changing rapidly due to that greenhouse effect and that added carbon dioxide. I wonder, where is all that carbon dioxide going? Like the heat that's being trapped in our atmosphere by the carbon dioxide that we're adding, the greenhouse gas mixture has been perfect for years, keeping our climate just right. We're adding a lot more CO2 that's changing the climate rapidly. Well, like the heat that is being trapped by that carbon dioxide, that's mostly going into the ocean. In fact, the carbon dioxide is going into the ocean at a very rapid rate. In this blue marble image from NASA scientists Rito Stokely and Robert Simon, you can see that beautiful globe and how almost 3/4 of the Earth's surface is water. That is the sink into which much of the carbon dioxide we're creating is flowing. In fact, 1/3 of all the carbon dioxide we've pumped into the atmosphere recently has gone straight into the oceans. And in fact, CO2, carbon dioxide, dissolves readily in water. It actually adds to the water, dissolves very quickly, and then it changes form. Among other things, it becomes carbonic acid. So adding carbon dioxide to the atmosphere causes the oceans to become more acidic. That's a hidden, added danger of climate change. It's called ocean acidification. Not only is the ocean warming, which tips the balance of life that can live there, and it causes sea level rise. We've talked about that before. But adding carbon dioxide to the ocean causes the oceans to become more acidic. So let's do an experiment where we can look at that acidification process. It starts actually in my kitchen with red cabbage. And you can do this at home. We'll talk in the future about this exact recipe. But by pouring boiling water over chopped up red cabbage and then letting it cool overnight, you get this beautiful purple liquid. It has a molecule in it called anthocyanin. And that purple molecule will change its shape and change its ability to interact with light depending on the acidity of the solution that it's in. These 2 glasses of water are neutral pH. And if I add a little bit of the pH indicator, you'll see that beautiful purple color. There we go. Now what happens, though, if we add a little bit of acid to one of those glasses? Well, I have here a little dollop of vinegar. Vinegar is actually it's 4% acetic acid. And if I add that vinegar to the solution, you see it rapidly turns pink. Well, carbon dioxide, when it dissolves into seawater, also turns the water acidic. And we may be able to see that if we add some carbon dioxide to this pH indicator. So let's try that. I have here that same pH indicator, but I've measured it out so we get exactly the same amount in each of these 2 bottles. There's our purple pH indicator in the first bottle, and here's our purple pH indicator in the second bottle. And now the experiment we want to do is to test the hypothesis that CO2 on water will acidify the water. Well, we're going to need CO2, so let's try our handy-dandy carbon dioxide factory here. This is 1 tablespoon of baking soda, and about 1/2 cup, it's 200 mils of vinegar. And what I'm going to do is pour the vinegar into the baking soda. That'll rapidly generate carbon dioxide, and I want that carbon dioxide to go into this bottle. So since carbon dioxide is heavy, it'll sink, and I'm going to start that now. So there comes the carbon dioxide. It's heavier than air, so I pour this vinegar in, and then I pour the carbon dioxide, just the gas, not the liquid, into this second bottle here. Okay, squeezing it out, squeezing it out. So if there is carbon dioxide in there, it should be filling the bottle now. And if there's some, I should be able to also fill this beaker. Let's just test to make sure we're getting carbon dioxide in those spaces. All right. There's our CO2. And now if there is CO2 in that beaker and in the bottle, then a match that'll burn in air will not burn in the CO2. So now we can assume that there's also CO2 in that bottle, since that's where I started pouring it. And I've got a bottle with just our pH indicator and air, and a bottle with the pH indicator and mostly carbon dioxide. And now we just need to mix them. This is a very straightforward reaction. And if it's the case that carbon dioxide dissolves readily in water, and it's true that carbon dioxide becomes carbonic acid, then we should get a color change where, sure enough, the pH indicator that's in the neutral solution just dissolved with air is still that same color, but the pH indicator that is in the water with added carbon dioxide is showing that carbonic acid has made this water more acidic. So then, what's the consequences of this acidification process? It is very well understood, and it's immediate, that adding carbon dioxide to water will cause the acidity to change, the pH to drop, the acidity to rise. Well, it turns out seashells are made from calcium carbonate. That stone-like material is calcium carbonate, and lots of marine creatures use that to make their shells. Calcium carbonate dissolves in acidic water. That makes it hard for the shell-making creatures first to lay down their shell when they're young, but then to keep their shells as they get older. In fact, in this image from David Lischwager at the National Geographic, based on research from Orr and colleagues in 2005, you can see what happens to the shell of a marine snail called a pteropod, common in the Antarctic waters, if it's placed in seawater of the acidity we are headed toward in about 80 years. It's not centuries, it's decades away, these changes. And you can see that that seashell is dissolving in just a little more than a month in this pH, in this acidity of seawater that we're headed towards. So, since more than a quarter of the life in the oceans depends on coral reefs, here we have a coral itself, for at least part of their life cycle, many species are at risk from this little-known additional effect of our addition of carbon dioxide to our atmosphere. So ocean acidification is another reason for us to change the experiment we're currently trying. Instead of adding more and more carbon dioxide to the atmosphere and headed towards a point where evidence shows that life in our oceans will be severely impacted, let's try the next experiment. Bring the carbon dioxide emission levels back down to see if we can't slow that change that we're not happy with right now. Evidence shows that that's an experiment worth trying. So, there you have it, another episode of Science with Dr. Bob, and until next time, keep on experimenting.